quick reminder, today we're doing section 3.2. If you check your gold sheet, tomorrow is a review day. Wednesday is your quiz for the first two sections of chapter 3. So you'll be taking a quiz on Wednesday. I'll give you back your concept checks from Friday at the end of class today so that you can look those over and examine some of your mistakes. Yes, sir? They will be. They are not, but they will be. More to come later. So notes 3.2 is all about complex numbers, and I'm going to ask the question, like, why do we even have complex numbers? What's the point? So here's my question to you. What is the square root of negative 36? Nothing. Okay, we've kind of mentioned this a few times. So a lot of times people instantly think about 6, but then 6 times 6 is positive 36, right? So then they switch gears and they say negative 6, but negative 6 times negative 6 is still positive 36. So if we're talking about the definition of a square root, a number times itself, there isn't one. Okay? So there is no number, no real number, positive or negative, that can be multiplied by itself and result in a negative number. Hence, the introduction of complex numbers. TJ, what's your question? Okay. So like up until we had complex numbers, this was just like a moment where you stopped. And in section 3.1, we just stopped, right? When we got to this point, we were like, that's not a real number, so no real solution. Moving on. Okay. From here forward, no real solution is not an acceptable answer if you're asked to solve an equation. You'll find me the complex solution, which may have imaginary parts. Okay, so first we're going to start off with the imaginary unit. So imagine back in the day, mathematicians solving quadratic equation, working out something, and then they get to that part we got to in section 3.1, and it was no real solution. They were like, hey, I'd really like to just have like a placeholder right here so that I could keep using this fake solution or the solution that isn't real. Okay, so I could just keep using it and see what I can do with it. So then they just decided, let's just make up a unit. We'll call it the imaginary unit. And it's the letter I. So that's nice because it means imaginary, right? And we'll say that I is equal to the square root of negative 1, which we would all agree doesn't exist. So now what's really great about I is, instead of leaving it as the square root of a negative number, which if we showed to some lower level math students, they might think is an actual answer, if we replace that square root of a negative number with an I, then that will signal to everybody this is imaginary. So I like it because it stands out, and then when you see it, you know that's not real. Okay? Whereas sometimes if you see the square root of negative 36, you might be tempted to think about 6 or negative 6. Okay? Now, if I is equal to the square root of negative 1, then we can use this to do other simplifying radicals. So if I did the square root of negative 4, I'm going to do a little bit more work here. That's really the square root of negative 1 times 4, which in properties of radicals is the square root of negative 1 times the square root of 4, which we know the square root of negative 1 is I, and the square root of 4 is 2, so the square root of negative 4 is 2i. Now, you can probably get to that answer without all these middle steps, right? What's the square root of negative 9? 3i. What's the square root of negative 16? 4i. Don't call anybody 4i. What's the square root of negative 7? Logan, I times the square root of 7. It's as good as it's going to get, right? What's the square root of negative 8?
Oh no, it's like 2.
Okay, very good. So some of us are recognizing 8 has a perfect square factor. So then we've got to go through that work to simplify the perfect square factor. That will be the square root of 4 is 2i, and then the square root of 2 is left over. So you'll have some problems on the homework assignment where they're just asking you to simplify things that have negatives underneath the radical. And they might even have something like, let's say I do 2 square root negative 45. Okay? So that just means like in the end, anything that I pull out of the square root is going to be multiplied by 2. Okay? Now, because it's a negative, I'm going to pull out an I, and then I just have to think like, what is the square root of 45? Square root of 9 times 5, which is 3 square root 5. So we can say 2 times 3i square root 5. That's just 6i square root 5. Now, based on your level of comfort with radicals, you may be writing down more work. And some of us may be able to do some of the radicals in our head. Okay. You kind of decide where you're at. If you need to write down the square root of 45 is the square root of 9 times 5 so that you can do 3 square root of 5 correctly, please do that. Okay. Anybody got any questions about that? Okay, so the big takeaway here is that when you see those numbers, when they have I in them, you instantly know they're imaginary, so they're not going to show up in the real coordinate plane. So now you're going to have some problems where they ask you to solve quadratic equations, and we're not going to stop at no real solutions. We're going to keep going.
Yay.
Yes. So we have 3x squared plus 1 equals negative 9. All right, so I'd start by looking at this and saying, hey, there's only one x squared right there. I could solve by reverse PEMDAS, taking square roots, right? Get x squared all by itself. So what would you do first? Subtract 1. We got 3x squared equals negative 10. Next. Divide by 3. X squared equals negative 10 thirds. Next. Square root everything. So x equals plus or minus. Don't forget when you square root to solve that there are now 2 answers because you're in algebra. You don't know if it was positive times positive or negative times negative. So you gotta have that plus or minus. And then if we're doing the square root of negative 10 thirds, we know it's an imaginary number, so we can pull out the I. And then we'll practice this again. We talked about this one other time earlier in this chapter, that this is really like the square root of 10 over the square root of 3. Property of radicals says I can break them up. And then remember that old school rule I talked about, you're not allowed to leave the radical in the denominator. So now we've got to rationalize our denominator. What would I need to multiply by? The radical 3 on the top and bottom, so that's our well-chosen 1. We're multiplying it by 1 so it stays the same, but we're making it look different. And so your final answer here would be plus or minus I square root 30 divided by 3. Well, sometimes they'll come out nicer than that, but I didn't want to do one of those ones where we have to rationalize the denominator because I couldn't use extra practice there. Anybody got any questions about that? Okay, why don't you work on this one and you can talk to your group members for ideas if you need to. Oops, I'm missing a parenthesis right there. Why don't you work on this one for me? 2 times x plus 1 quantity squared equals negative 16. See if you could solve. What'd you guys do first?
Divided by 2.
Divide by the 2. Good. So we get x plus 1 quantity squared equals -8. Then we're going to square root. We're not ready to subtract 1 because it's trapped in those parentheses. So I have x plus 1 equals plus or minus I square root of 8.
2i.
2i radical 2. Got to simplify your radical, right? And then the last thing would be subtract 1. Okay, so x equals, I'm going to put -1 in front, plus or minus 2i square root 2. How many answers are there? There's 2, right? One of the solutions is -1 plus 2i square root 2, and the other solution is -1 minus 2i square root 2.
On our assignment,
You
you have to write that out.
don't have to write them out separately. I'm just trying to make a point. Okay, because some people on your concept checked on Friday, you didn't separate them out. Now, the only time you would want to think about that is when they both come out to nice numbers, right? So if it's -2 plus or minus 5, that's -2 plus 5, which is 3, and -2 minus 5, which is -7. So you should then give real number answers. So just know that there are 2 options there. In this case, I would take either answer. Okay, any other questions or concerns on that? Okay, so that's how we're going to be actually using complex numbers in our work. And you're going to see complex numbers when we get to quadratic formula as well. It's going to sometimes have square roots of negatives, so we're going to be writing those as i's. And our answers are going to come out to look a lot like this, -1 plus or minus 2i square root 2. That's why I always put the number in front of the plus or minus, because that's what the quadratic formula generates. So all of our stuff looks the same. Okay. And then some other things that we can do with the complex numbers are basic operations. So we're just going to review how the number system works. Okay, this is not really related to solving quadratics. It's just understanding complex numbers. So every complex number comes in something called standard form. And when mathematicians decide something is called standard form, then that's like a call to all mathematicians. Everybody write your answers this way. And if we say that, then my answer will look like Leon's answer, will look like Lila's answers. Everybody's will be the same. And so we want to write our complex numbers in standard form, a plus bi. And that kind of goes back to as well on the last slide, why I would write it -1 plus or minus 2i square root 2. Then it looks like the standard form. So we're all writing our numbers the same way. Now, in that form, you have 2 parts. A is made up of your real part, and bi is made up of your imaginary part. So you didn't know this all these years, but all the numbers you've ever worked with are really complex. 1, 2, 3, 4. That's 1 plus 0i, 2 plus 0i, 3 plus 0i, and 4 plus 0i. But we never felt we needed to tell you about the 0i until then. So you know how you used to have the real number box of all numbers? And you could break that up into irrational and rational numbers, subsets. And then in the rational numbers, you have integers and whole numbers and natural numbers. Okay. Now your box just got bigger. Okay. Around real numbers are the complex numbers. Okay. So even real numbers are a subset of the complex numbers. Things like 1 plus 0i and 2 plus 0i. Okay. Those are considered real numbers. Imaginary numbers come in the form sometimes it might be 2 plus 3i, or maybe it's just 4i, but if it has some imaginary part, then it's going to be an imaginary number. Okay, so these are imaginary numbers. Oops. Imaginary numbers, and these are real numbers. I am totally okay if you write real numbers as 1, 2, 3. You don't have to write them in standard form from now on. Okay. So, I'm going to actually let you chat with the people at your groups. If I gave you two complex numbers and asked you to add or subtract them, what would you do? So, tell your group members what you think might be an appropriate solution for adding or subtracting. What do you think you might do?
You're right. Use the negative. Wait, no. Wait a minute. You're right. It is 4i. Because the negative carries over to the negative 3i instead of positive 3i. So you're right.
Yeah, I like your idea. Again. I have something else different.
I forgot how to.
You're on the right track. Okay, let me ask this to the class. Any groups think they got a good idea for adding the first two numbers? 3 minus 2i plus 4 plus 2i? You got 7? How did you get 7 from that? Okay, negative 2i plus positive 2i is how many i's? 0 i's. And then 3 plus 4 is 7. So sometimes complex imaginary numbers might add together and make a real number if all the imaginary parts disappear. Essentially, what you're doing is combining like terms. It doesn't matter what level of math you're in. It doesn't matter what level of math you're in. Adding and subtracting is always combining like terms. Doesn't matter what chapter, what class. If you want to add and subtract, you should combine like terms. So what are you going to do for subtracting? Lilith?
So first we had a problem because we were like, well, how do we add this up? But then we noticed the negative in front of the negative 2 and the negative 3i. So first you could add together your i's, which would give you, wait a minute, which would give you 4i, because it would change from a negative 3i to a positive 3i. So you would get
Okay.
4i, and then
I think they're hitting on a really great point there, is that you're subtracting the whole complex number, negative 2 minus 3i. I recommend, for me personally, I'm going to get most accurate answers if I distribute my negative right away. So when I distribute my negative, that means I'm changing it into addition. So this is really plus, and then change the signs of both numbers, 2i plus 3i. And then I could do what I just did, right? Combine like terms. 8 plus 2 is 10. I plus 3i is 4i. Okay, so those are on your quiz on Wednesday. Those should be pretty easy points, right? Combine like terms? Okay. It's so easy.
are we getting to? I'm scared. I don't
Yeah,
want
we're
to
going to do multiplication next. Thanks, Quinn. So, talk to your group members. What do you instinctively want to do first?
I don't like this. I don't know if I is scared. You got 2i times 3i. So would that give you like 6i? Wild. What a wild time. I feel like the first one.
Okay. Leon, will you tell us what your group talked about? What you would do to multiply?
I said that we should just treat them as normal variables and continue with what we've been learning recently. At least,
I mean, I think that's a great strategy for I, right? Like we understand I to be the imaginary unit, but when we're multiplying, let's just treat it like it was an X, right? So probably most groups decided to do some kind of distribution. So 2i times 5 is 10i. And 2i times 3i is 6i squared. Now, our one issue with that is that's not in standard form. It doesn't look like a plus bi. So we're going to have to fix the 6i squared. Do we know anything about I squared?
would cancel
Okay.
itself out.
Our table was talking about how I equals the square root of -1, so I squared would just be -1.
Did we all agree to the imaginary unit? Okay. So if we square both sides there, then we'll come up with I squared equals -1. It's a real number. Isn't that like what the definition of a square root is? If you take it times itself, you get the thing underneath. So if we're taking the square root of -1 times the square root of -1, we should just get -1, even though there isn't a real number that does that for us. But the i's are. Okay, make sure this is somewhere in your notes where you can see it. It's really bright. It's big. I squared equals -1, you need to know that. So then this is 10i plus 6 times -1. Write it in standard form. That's -6 plus 10i. And then we could do that again for a trinomial down here. Just FOIL this out, distribute this like normal, right? 12 plus 8i minus 3i. Be careful here on the last one. It's a negative times a positive, so it's negative. And I times 2i would be 2i squared. You can combine your middle terms right here. That's 5i. And this is really -2 times -1, which is plus 2. So 2 plus 4 or 12 is 14. Okay. So something for us to practice and be prepared for coming up to Wednesday. If you leave your answers for multiplication with I squared, you will not get full credit because it's not in standard form. So it is your responsibility when you see I squared to change it to a -1. So this is just how all mathematicians have agreed to work with the set of complex numbers so that, again, all of our answers will still look the same depending on what we're doing with those numbers. Okay? Anybody got any questions for me? Okay, your homework assignment, just to kind of clarify, I've got all these sets of problems, but what I'm requiring you to do are the odds. And what do I want you to do with the odds before you come in tomorrow? Check them. That way you know if you're doing them right. If you're doing 5, 7, 9, 11, and they're all wrong, maybe you need to come in for help. Try a new section. Can you get 21, 23, 25? Okay. So within each of those sections, there might be a new set of directions. See which sections you can do and which ones you have questions about. If you're interested in the chapter 1 to 2 retakes, those are due this Friday. I am out of retake forms right now, but I'll get copies today after school, so those will be available tomorrow. If you know you're planning to retake it, you might want to see me so we can at least tentatively schedule a date and make sure that we're both okay for that. And then I'm going to pass back your concept checks. So just as a real quick review of what I did. All I went through is highlighted problems that you got wrong. So that means they need a second look. You're going to redo the entire problem that you got wrong. You can do it on the side in a different color, or you can do it on the back. Okay, leave me a note where it is. And then you're going to turn that back in, and then it will be graded. So you've got a chance to practice. Think ahead to your quiz on Wednesday. What if you got all those wrong on your quiz? That would be a bummer. So what do you need to fix before Wednesday?